Training video for the PD230 inductive loop vehicle detector. The PD230 is a dual-channel microprocessor-based detector designed specifically for parking and vehicle access control applications. There are other products available for high-speed and motorway operation. It should be noted that there are lookalike products sold in this market not manufactured by Nortech. The information in this video may not be necessarily correct for any lookalike product. Check for the embossed Nortech logo on the detector housing to confirm that it is a Nortech product. Principle of operation. An inductive loop vehicle detector senses the presence of a vehicle over an area defined by a loop of 2 or more turns of wire, laid under the road or pavement surface. A vehicle passing over a sensing loop is sensed by the detector. Upon detection of a vehicle, the detector operates output relays, which may be used to initiate controls associated with the installation. The PD230 is available in 2 voltage versions. Refer to the side label to determine the model in use. A mains voltage version designated PD232 is for operation with 240 volt AC mains voltage. The part numbers and description for the mains voltage units with differing output configurations are shown. The PD234 is a low-voltage version for use with low-voltage DC supplies in a range of 9 volts to 40 volts. The part numbers and description for the low-voltage units with differing output configurations are shown. Detector configuration. The unit has controls and visual indicators at the front of the unit. All inputs and outputs are all connected to a single 11-pin plug, at the rear of the unit. The vehicle detector has 3 pins dedicated to the voltage supply and an earth connection. The earth connection is important for the operation of the lightning protection provided to protect the loop inputs. 2 pins are used for the connection of each of the 2 inductive loops. The twisted cable pair between the roadway loop and the detector is called the loop feeder. The remaining connections are allocated to the output relay contacts that operate the equipment connected to these outputs. The detector has a number of switches and visual indications on the faceplate of the unit. The switches allow for different loop frequency settings, sensitivity settings and mode settings. The detector has 3 indicators on the face of the unit. A red indicator that illuminates when the unit is powered. 2 green indicators that indicate the status of each of the loops and illuminates when a vehicle is detected. The 10-way mode switch allows adjustment of site-dependent settings. The function of these will be described in detail. Tuning of the detector is fully automatic. When power is applied to the detector, or when a reset is initiated, the detector will automatically tune itself to the loop to which it is connected. The detector will tune to any loop with inductance range 20 to 1500 microhenries. Once tuned, any slow environmental change in loop inductance is fed to a compensating circuit within the detector that keeps the detector correctly tuned. On power up, the red indicator on the detector will illuminate permanently to indicate that the unit is functional. While the detector is tuning, the green output indicators will also illuminate and then extinguish after a few seconds when the system is tuned. Once tuned, a green indicator will illuminate whenever a vehicle is detected over one of the inductive loops. If a loop becomes faulty once the detector is tuned, the green indicator will continually flash off and on at the rate of 2 Hz to identify the fault. If the fault is self-healing, the detector will resume operation, but the indicator will remain on, to show that a fault has occurred. In this state, the indicator will go off for a moment during an undetect, thereafter returning on. Once faults are cleared, the indications can be restored to normal by resetting the detector. Detector operating frequency. The detector energizes the loop with a signal in the range 20 to 150 kHz. Where installations have more than one inductive loop in close proximity, detectors must be operated at different frequencies to prevent interference with each other. This interference is called crosstalk. Crosstalk is identified by spurious outputs from the detector or an output permanently on or slow to release following a detect. These outputs are unrelated to vehicle movements over the loop. Interference is eliminated by ensuring that the loops associated with different detectors are spaced sufficiently apart, and also ensuring that the detectors are set to different frequencies. The frequency switches on the face of the unit allow the loop to be shifted higher or lower depending on the switch position. Two switches SW1 and SW2 on the face of the detector provide 4 frequency settings as shown. Where only one detector is installed, any frequency may be used. With additional detector units installed, the frequency of each unit must be altered until no spurious outputs are apparent. Detector sensitivity. Sensitivity of the detection system is dependent on factors such as loop size, number of turns in the loop, feeder length and the presence of metal reinforcing in the roadway beneath the loop. The nature of the application determines the required detector sensitivity. The lower sensitivity settings of the detector will prevent the detection of bicycles and trolleys, whilst high-bed vehicles and vehicle-trailer combinations will require a higher sensitivity setting to prevent detector dropout between axles. Note that the maximum sensitivity setting can result in spurious detector outputs in environments of high electrical noise and unwanted detection in adjacent traffic lanes. 4 sensitivity switches on the face of the detector provide for 4 sensitivity settings for each loop as shown. Medium-high is the recommended default setting. Automatic sensitivity boost is a mode that alters the undetect level of the detector. When turned on, it causes the detector sensitivity to be boosted to a maximum on detection of a vehicle, and maintained at this level during the presence of the entire vehicle over the loop. When the vehicle departs the loop and the detection is lost, the sensitivity reverts to the pre-selected level. This setting will assist in maintaining detection of high-bed vehicles and vehicle-trailer combinations while still operating at a lower sensitivity setting. The ASB mode is selected by SW7 as shown. Normally the detector will be operated with this mode turned off. Detector output configuration. The PD230 has 2 output relays. One relay is associated with each of the 2 channels. These outputs will provide either normally open or normally closed contacts depending on the model number. The detector outputs are fail-safe, which means that in the event of a loop or power failure the detector outputs will fail in a vehicle present condition. Normally the presence output is available for only a limited time due to the environmental compensation circuitry of the detector. The detection memory time will be dependent on the change of inductance due to the vehicle over the loop. The presence time on the limited presence setting will be approximately 1 hour for a 3% inductance change. In some applications it is a requirement for a longer or even indefinite presence time. This is made possible by the presence time selection on SW8. If permanent presence is selected, then the presence output is maintained indefinitely, to the detriment of the environmental compensation that operates only when the loop is unoccupied. Permanent presence should only be used when necessary, as disabling the environmental compensation can is certain conditions cause detector lockup requiring a service call to reset the detector. The output relay for each channel may be set to either pulse mode or presence mode with the setting of SW9 and SW10. Presence mode provides a continuous output for the duration of the vehicle over the loop, subject to the presence time setting. Pulse mode provides a short duration pulse of 150 milliseconds duration on arrival of a vehicle. Direction logic mode. The PD230 can be used to sense vehicle direction. In this mode, a vehicle traveling over the 2 loops in a direction from A to B will operate the Channel 1 relay, while a vehicle traveling in the opposite direction will operate the Channel 2 relay. For this logic to operate correctly, the loop spacing must be less than the shortest vehicle, so that each vehicle bridges the gap between the loops. Direction logic mode is selected with internal links on the circuit board that can be accessed by removing the circuit board from the housing. The diagram shows the location and setting of these links. The detector output in this mode can be either a presence output or a pulse output depending on the link fitted. The presence output duration is from the time that the vehicle reaches the front edge of the second loop in the direction of travel until the vehicle vacates this second loop. Connections to the detector are made either with a DIN rail mounting base incorporating screw terminals or shelf-mounted using a pre-made wiring harness. Details of these connections are shown in the table. The installation checklist is shown here. The loop cabling must have low electrical resistance and protection against moisture ingress to ensure reliable operation. In existing sites, damage to the roadway, the loop slots and the slot sealant is an indication of a potentially unreliable installation. The presence of metal in the loop area, in particular steel mesh in concrete roadways, may cause a reduction in detection sensitivity. Loop feeder cables must be tightly twisted right up to the detector terminals to prevent false operation of the detector. High-voltage electrical cables and inductive machinery in the loop area will increase the chance of electrical interference with detector operation. The detector setup items shown represent those most likely to cause difficulties with reliable detector operation. Ensure that the correct PD230 model is in use, as the relay contacts of the various models are not all configured the same way. Detector frequency settings are important in multi-detector operation to prevent interference between installed loops. The maximum sensitivity setting is not ideal in all situations. High sensitivity makes the detector less immune to electrical noise and crosstalk as well as unwanted detection from adjacent loops. Lowest settings are unlikely to be successful for detection of high-bed vehicles. Other detector options including permanent presence, ASB and direction logic mode should be applied with the necessary caution. PD230 related part numbers are shown here. This concludes the PD230 training video. Please refer to the user manual for more information on the PD230. An application note on loop installation is also available.